Assalamualaikum and hi class. In this video, we're going to discuss about the confidence interval formula that you can use to estimate population proportion. Let me ask you, do you know what is population proportions? I'm pretty sure this is the first time you ever heard of the word proportions. I mean, you know what is population mean, you understand what is population standard deviation, but do you know what is population proportion? How does proportion helps you to understand about your data? Okay, so let's look at the literal meaning of proportion. Literally, it means a part of the whole. For example, here you see there is a box, and in this box, there are 5 balls. Okay, there are 4 blue balls and 1 red balls. So in this case, in this scenario, I can say that the proportion of blue ball in the box is 4/5. Which is also equivalent to 0.8, because if you take 4 divided by 5, you will get 0.8, and this is also equivalent to 80%, which means that 80% of this box contain blue balls, and if you were to pick one ball, without looking at the box, if you were to pick one ball, the probability of you getting blue ball is 0.8. And in the same way, the proportion of red ball in the box is 1/5, which is also equivalent to 0.2, and this is also equivalent to 20%. So you see, class, the proportion of something, can be described in terms of fraction, probability, or also in percentage. So this is proportion. So in a statistical study, you might not you will not be interested about finding out blue balls or red balls. So let us consider another situation. So let's imagine that this is the population of all UMP students. Okay, and let's just imagine that we are trying to do a study about COVID-19. Okay, so perhaps instead of finding out blue or red balls, maybe the interest here is to find out the proportion of students who has been infected with COVID-19 for at least once, or maybe the proportion of students who never been infected with COVID-19. Okay, so in such a study that involves proportion, we will define one of these category as success and the other one as failure. Okay, remember, in a analysis that involve proportion, you will need to define one of the category as success and another one as failure, and in such study, we will only categorize the population into 2 categories, okay, only into 2 groups. One of it will be success, another one will be failure. So here, come back to the population. What we're trying to do in this research is we're trying to understand or to determine what is the population proportions of students who has been infected with COVID-19 for at least once. But then again, if we were to collect this data from the whole UMP students, okay, that would be too much work maybe, alright? So instead of doing that, we may just took a sample of students, okay, maybe we just took a 500 students here, and then we interview them, okay? So we just give them a questionnaire and ask them, have you been infected with COVID-19? So the students will answer yes or no, and then you count how many of them answered yes, how many of them answered no. So let's say 100 out of the 500 students answered yes, which means the number of students who has been infected with COVID-19 for at least once is 100. So from there, we can find out that the sample proportions, okay, the proportions of students who has been infected with COVID-19 for at least once from this sample is 0.2. Am I right? 100/500 is also equivalent to 0.2. So P here is the notation that we use to represent sample proportion of success. Okay, so in other words, this P here is the sample proportions of students who has been infected from COVID-19 from this sample. Okay, so class, this is the sample proportions. This does not mean that the whole proportions, okay, the whole population, I'm sorry. So it does not necessarily mean that the whole populations will also gives us a proportion of 0.2. Okay, if you find out that 20% of the sample has been infected by COVID-19, it does not necessarily mean 20% of the population has also been infected with COVID-19 for at least once. Okay, but what you can do with this sample value, with this sample proportion, is you can use it to estimate your population proportions. Okay, so when you conduct a certain study, of course, what you're trying to find out is actually about the population, not just about the sample. So instead of collecting data from the whole population, you can just use the sample information to estimate your population information. Okay, so in this video, we're gonna learn about how can you use P, which is sample proportion, to estimate pi. So pi here is the notation for population proportion. So in this particular case, we actually want to know about the population proportion of students who has been infected by COVID-19, and we're going to estimate it using P, which is the sample proportion. Okay, so P is for sample and pi is for population. Okay, so a population proportion pi is a parameter that describes a percentage value or probability of success associated with a population. So yeah, as I said before, you need to define what is the success for each proportion study. Okay, so let's look at the formula. This is the formula. P minus Z critical value, okay, Z alpha over 2 multiply with square root P multiply 1 minus P, and all of this divided by N. So that is your lower boundary formula, and for the upper boundary it's actually the same thing, but you just had to do addition instead of subtraction. Okay, so P here is the sample proportion, and the formula to get P is X over N. X here is the number of success in a given sample size, and N here is the sample size. For example, just now, 100 students divided by 500. So 100 is the number of success, which is the number of infected COVID-19 students. Okay, so that is one example lah. Okay, and Q is the proportion of failure. P is the proportion of success, and Q is actually the proportion of failure because it is 1 minus P. Okay, and then you need to also be informed that your population proportion will be within the range of 0 and 1. Okay, so same goes to your P value. Your P here should be in the range of 0 and 1. You should never calculate P and you get negative value, and you should never calculate P and you get more than 1. So your confidence interval to estimate pi, your confidence interval also has to be within this range. So this might be like a good tips lah. If you calculate the confidence interval and you get negative value, that means something is wrong with your calculation. And if you get more than 1, that also shows there is something wrong with your calculation. So this is the range lah for proportions. So now let's take a look at one example. Okay, in this example, you're given the information about the fraction of defective integrated circuits produced in a photolithography process is being studied. Okay, so this is about defective circuits. A random sample of 200 circuits is tested. So this is the sample size, revealing 13 defectives. Okay, which means that out of the 200 circuits, 13 results to be defectives. Question A. Calculate a 95% confidence interval on the fraction of defective circuits produced by this process and give a comment on the resulted confidence interval. So yeah, you need to calculate confidence interval on the fraction. Okay, even though the question did not mention proportion, but as explained earlier, proportion can also be represented by fraction, probability, or percentage. So if you see the word fraction in your instruction in the question, so that is also equivalent to proportion. Okay, and same goes if you see percentage in the instruction, it also means proportion. So basically the instruction is for you to find confidence interval on the proportion of defective circuits. Okay, so from this instruction here, you should first understand what is the variable, what is the sample, and what is the populations. For a proportion study, for proportion questions, the variable is number of success. Okay, number of defective circuits. Okay, so this is a little bit different from the previous examples in the previous subtopics. Untuk proportion, the variable will start with the word number, and then you need to find out lah from the question number of apa. Okay, so in this case, it is number of defective circuits. The sample is 200 circuits, so the population could be all circuits. So you will use this formula, and to be able to use this formula, you need to find out what is P. You know what is N. You can get Z from the table. So now let's discuss about P. So P is X over N. Remember, X is the number of success, and N is the number of sample size. So you need to define what is your success in this question. So you can define it from the instruction given. Okay, so you see here, the instruction want you to find confidence interval on the fraction of defective circuits. Okay, so therefore now you know the success is defective circuits. Alright, so you can define the success from the given instruction. So now, what is the number of success then? What is the number of defective circuits from the sample? So yes, 13 defectives. So P is equivalent to 13 divided by 200. Yes. Okay, so that's easy. So once you have all the numbers, all the values you need, okay, find P, find critical value, and substitute them into this formula. And then there you have it. You have the confidence interval to estimate the population proportion of defective circuits for this study. Alright, so please take note that for confidence interval for population proportion, there is no unit. Okay, there is no unit required to be written down in your answer. So the probability of the population proportion to be within 0.0308 and 0.0992 is 0.95. Interpretation, we are 95% confident that the fraction of defective integrated circuits produced in the photolithography process is between 3.08% and 9.92%. So yeah, for interpretation, it's actually preferable for you to change this probability form into percentage form. Okay, just multiply by 100. Okay, multiply by 100. And there you can have the confidence. This is how you estimate population proportion. You estimate pi using P. Okay, so I hope that is clear. But if you do have any question, you can just PM me anytime, immediately right now, okay? So next, let us look at the second question. How large the sample would be if we wish to be at least 95% confident that the error in estimating P is less than 0.02. Okay, class. So this question is not asking you to calculate the confidence interval. No, okay? Look at it again. The question is actually asking you about how large the sample would be. So this is actually asking you to calculate the sample size. What is the minimum sample size that you need to include in the study in order to get a confidence interval which has estimation error less than 0.02. So this is what the question is about. Okay, so to find the optimum sample size for the case of population proportion, you need to use this formula. Okay, so this is another formula which is different from chapter 2.2. Okay, so the formula is given by critical value divided by E, and then you square root, you multiply with P bracket 1 minus P. Okay, so if you look at your formula book, I think I don't remember which page it is, but you will find that there are two formula for sample size. One is for chapter 2.2 and another one is for chapter 2.4. So which formula to use, class? That depends on the question. If the question talks about population proportion, so you use this formula. If the question talks about population mean, so you use the other formula from chapter 2.2. Okay, is that clear? Remember that, okay? And also there's another note here. If the sample proportion is not given in the question, the value of sample proportion is considered equal. That is, P equals to Q equals to 0.5. So if you ever encounter or see a question that asks you about the sample size, but they don't give you any sample proportion, okay, any information about the sample proportion, so you can just assume it to be 0.5. So please take note on this, okay? But for this case, in this question, we already know what is the sample proportion. It's 13/200. Okay, so we will use this P to calculate the sample size. Okay, so 1.96 is the critical value. 95%, so alpha would be 0.05. Alpha divided by 2 is 0.025. So Z 0.025 is 1.96, right? So divided by 0.02, this is the estimation error, which is already given in the question. Yes, the estimation error will be given in the question. And then you multiply with P, calculated from the information up here, and 1 minus P, and you will get 583.6831. And same as chapter 2.2, for sample size formula, we round up. Okay, we round up. We round up to the next greater integer. 583 becomes 584 circuits. Okay, so which means that if they do this experiment, if they consider 584 circuits instead of just 200 circuits, and then the estimation error made will be smaller. Okay, their estimation will be better if they collect data using 584 samples instead of just 200. So this is how you answer question B. Moving on, there's another one question, okay? The last one is construct a one-sided 95% lower bound confidence interval on the fraction of defective circuits produced by this process. Give an interpretation of the parameter estimate. So this question want you to calculate the confidence interval, but not the standard confidence interval, but the one-sided, okay? And here it is the one-sided lower bound, which is given by this formula. For the lower bound formula, the lower boundary is given by P minus Z alpha. Alright, so instead of in the standard formula, the lower boundary is Z alpha over 2, but for the one-sided lower bound formula, the lower boundary here is Z alpha. Okay, itu je, that's the only difference. So the one-sided lower bound formula is given by A, 1. The upper boundary is 1 because remember your proportion cannot be larger than 1. It should not be larger than 1. So the maximum value is 1. And for the one-sided upper bound, it will start with 0. Okay, so do you still remember earlier I told you that your proportion should be within 0 and 1. So that's why for the one-sided upper bound here, the minimum value, okay, the smallest possible value for your proportion is 0. 0, B. So the formula to find B is this, P plus Z alpha. Okay, let's come back to the question. The question wants us to find one-sided lower bound, so we will use this formula, okay? Right, so alpha here is 0.05. So you find Z 0.05, it will give you 1.6449. And then you substitute P, substitute the critical value, and calculate everything accordingly. You will get 0.0363,1. So also, please notice that in this confidence interval, we use open bracket for the lower boundary and we use closed bracket for the upper boundary. This is because because proportion can never be more than 1, so that is like the limit there. Okay, but don't worry, in your quizzes, in your test or final exam, if you don't use closed bracket for the upper boundary here, it doesn't really matter because I won't penalize you for that, but I just want you to know that the correct way to write this confidence interval is by using close bracket. And then no units, and the interpretation is we are 95% confident that the fraction of the defective integrated circuits produced in a photolithography process that contain one-sided lower bound is between 3.63% to 100%. That's it. Okay, that is how you use the confidence interval formula to estimate population proportion. Okay, I hope that is clear. I hope you understand my explanation. Next, we're gonna go to what is the formula to estimate the differences between two population proportions. So that will be my next video. Thank you for listening in. I'll see you in my next one. Bye.